A parallel universe has haunted not only scientists, but our entire civilization for a very long time. Until 2020, when the news broke out that NASA has finally detected proof of a parallel universe, a universe where time runs backwards. If you were thinking that it's just a conspiracy, then buckle up. Today on Curiosity Lounge, we are going to unravel the truth behind the parallel universe. Have we really found one? If not, what else can it be? This universe is immensely large, and it has shown many signs for a possible other one like ours. To understand this, let's go back to the creation of this universe. Our universe, with its hundreds of billions of galaxies and nearly innumerable stars, spanning tens of billions of light years, isn't the only one according to multiverse theory. There could be many more, each with their own set of different laws of physics and fundamental constants than ours. Collections of stars and galaxies, and possibly even their own civilization. Because the observable universe only stretches as far as light has traveled in 13.8 billion years since the Big Bang. Space-time, beyond that distance, can be considered a separate universe. A large number of universes coexists in this way, creating a massive patchwork quilt of realities. This concept may be difficult to believe, but it is based on sound physics. There isn't just one path to a multiverse. Several physics theories lead in that direction independently. In fact, some experts believe that hidden worlds are more likely to exist than not. If the multiverse theory is correct, another universe exists that is identical to our own. It is known that other universes could arise from a theory called eternal inflation. The idea of inflation is that the cosmos expanded quickly after the Big Bang, inflating like a balloon. The inflation didn't end everywhere at the same time. Well, it ended for everything that we can detect from Earth 13.8 billion years ago. Cosmic inflation, in fact, continues in other places. This inflationary principle indicates that, like a huge balloon, the cosmos expanded rapidly after the Big Bang. When the process of inflation was taking place on such a massive level, different pockets of space might have stopped inflating at different times, while other regions continued to inflate. This gave rise to multiple isolated bubble universes. These other bubble universes could have migrated away from us well beyond our ability to observe. It may have been away from our ability to observe, but not anymore. A NASA experiment has indicated the possibility of a parallel universe. With this Antarctic Impulsive Transient Antenna, or ANITA for short, also suddenly came into the limelight, and the cosmic ray shower that was key to the new discovery was a part of NASA's ANITA, an ice cube experiment taking place in Antarctica. NASA's ANITA instrument is a radio telescope that uses a scientific balloon to detect ultra-high-energy cosmic ray neutrinos. It entails an array of radio antennas attached to a helium balloon that flies at 37,000 meters above the Antarctic ice sheet. The antennas can listen to the cosmos and detect high-energy particle neutrinos from such a high altitude, which constantly bombard the planet. ANITA is the first nest observatory for neutrinos of any kind. The experiment was prepared in Manoa, Hawaii. Its goal was to catch radio waves emitted by neutrinos, a type of extremely elusive subatomic particle that hurls onto Earth from space and collides with atoms in the ice. Between 2006 and 2016, a balloon suspended its retro space cluster of radio antennas and solar panels to monitor a large area above Antarctica in 4 flights. The question here is why scientists studied neutrinos, or why it was an important part of the experiment and discovery. Astrophysicists are fascinated by neutrinos because they are the only particles that can reach Earth at all energies without being attenuated. This is especially important at high energies where other particles and photons interact with microwave background photons, preventing them from propagating and surviving over long astrophysical distances. To put it another way, if you want to see the ultra-high energy universe, you should view it through the light of neutrinos. But before we get into the result of ANITA, understand this. Because of the Ascarian effect, neutrinos with energies in the order of 10 to the 18th eV or electron volt produce radial pulses in the ice. These high-energy cosmic neutrinos are thought to be the result of ultra-high-energy cosmic rays colliding with photons and the cosmic microwave background radiation. The ANITA experiment was thus hoped to assist in explaining the origin of these cosmic rays. So, over the years, a handful of anomalous events have been detected by ANITA. Instead of coming from space, the high-energy neutrinos appear to have come from an unusual angle, passing through the Earth's interior before hitting the detector. That much is true. Our current understandings of physics cannot explain these findings. The ANITA anomalies drew cautious attention from the elementary particle physics community. They are one of the few findings that contradict the established theoretical framework but any overlooked issues with the experiment itself could likely produce a similar result. Well, that brings us to the end of our video. We hope you enjoyed it and learned something new. If you did, make sure to hit that like button and subscribe to Curiosity Lounge so that you never miss any amazing video from us.